So the core concept of our five. Yes. So hello everyone. So today we will be presenting about year farm aquaponics. The core concept of our 5-acre farm was centered on integrating aquaculture and crop production within a closed-loop system. Instead of treating fish farming and plant cultivation as separate operation, we link them together as in dedicated tanks where they are produced waste. This nutrient-rich water will be processed and route directly to our crops. Let's see for the next slide. Yang slide dulu. So, mana tadi ya? So tilapia fish are raised in dedicated tanks where they produce waste. This nutrient-rich water will process and route directly to our crops, including the leafy greens like bok choy, lettuce, and as well as the herbs. The plants also will absorb this vital nutrient, and naturally they will filter and purify the water. The clean and filtered water is then recirculated right back into the fish tank, creating a continuous zero waste cycle. So next. So for our objective, we have 4, which is integrated farming. We combine aquaculture and crop production into a single cohesive operation system. Secondly, resource recycling, where continuous recycle water and nutrient between the tilapia tanks and the crop beds. Thirdly, efficient soilless production, which we will be producing a high yield fresh living vegetable and herbs using a soilless aquaponics setup. And of course, smart farming integration, where we implement the IoT and smart technology to enhance farm management. For the farm layout, we design the space to raise the fish tank, the left side, and the solar panel is placed on the roof. But I don't place the roof here. So the solar is at the roof of the fish tank, and the fish tank will produce ammonia and pass through the water tank, and after that, filter through the mechanical filter to remove the solid waste, and biological filter that has nitrifying bacteria, which is Agroz and such to shrink the ammonia and nitrate. And the nitrate will be used as fertilizer in the irrigation system for our crops. And the crops we planted is basil, bok choy, and lettuce because they need the demand of the nitrate high. And in our greenhouse, we also have central cultivation bench and a nursery system. And there was a pond to cover the rainwater and feed the parking area and the office and the roof inside the farm. So next. For the area of allocation for the farm for the total of 5 hours, for our fish tank, we tend to design the fish tank for approximately 4,800 square feet as the total length of seven, and can refer all the line in favor. So farm component, the fish tank area, we choose to rear tilapia fish in this area. The fish produce waste such as ammonia, waste, which becomes a source of nutrients for plants after treatment. Aeration keeps water for health fish milk. For the mechanical filter, you remove the polymer part and treat water and untreated waste from the water before it goes to the biological filter. It protects the system from clogging. For the biological filter, beneficial bacteria converted the ammonia to nitrate and then to nitrate. The nitrate is safe for fish and is absorbed by the plant as the nitrogen nutrient. And the water tank is stored filter water and acts as a filter behavior. And the pump will move the water from the plants to the growing system and help maintain the circulation. And the media net is our legume growing area, and the overseas route system is used for the lettuce and factory. So next.
Moving on to the crop production, the crops that we cultivated are all using the nutrient-rich water that directly from the fish tank. We selected these three primary vegetable, which is bok choy, as it is a fast-growing leafy greens that thrive on available nitrates. Lettuce, another fast-growing leafy crops and can optimize the floating rock and soil system. And also we add basil. It's a high valuable crops grown in our media in our farm. As the water flow across the growing beds, the plant root from these primary crops will absorb the nutrient that they require for growth and effectively can clean the water before it being recycled back into the aquaculture. So for aquaculture, the fish that we selected is the breed or the species that we selected are tilapia, and the production is we rear it in a fish tank where this fish will produce waste containing the nutrient and the beneficial bacteria that we include in the fish pond can convert the fish waste into forms that the plant can absorb. And also after that, the nutrient that being converted by this beneficial bacteria can be absorbed by the plant for their essential nutrient. And after that, the filter water is circulated back towards the fish tank.
So now is the integration of smart farming and also things also that is IoT in our farm. Okay, so next is integration of smart farming and also IoT in our aquaponics system. So first is aquaculture monitoring. So for our farm, we are going to use AI-powered cameras, which is used to track growth and feeding strategies of the tilapia, so that we don't have to manually harvest the tilapia by hand. And second is acoustic feeding sensors through the use of hydrophones, which is used to capture ambient underwater noises or to create specific feeding schedules. So basically what it does is when there is no sound, that means the fish are already full, so they don't need any food. So next. Okay. So second is for hydroponic optimization, which is for the plants. So first is EC sensors, which is used to measure the concentration of dissolved nutrients in the nutrient solution. And second is pH sensors to monitor acidity. And third is vapor pressure decreasing to measure the temperature, which utilizes the use of temperature and also relative humidity sensors through smart climate sensors. Okay, third is precision water management. So this it uses a closed loop recirculation where continuous water is flowed from the tilapia to the through the biofilter to the grow beds. So as we can see in the here, it started from the fish tank, and any waste coming from the fish tank is going to go to the filter where it's going to filter any solid waste, and the solid waste will be transferred into the biofilter where the where the waste are going to be undergo a nitrification process where the ammonia are going to be converted into nitrates, which is the nutrient source for plants. And the water from plants will be recirculated back into the fish tank. Next. So the next one is waste and circular system. So first is the mechanical separation of solid filter to remove the solid waste. This is to prevent any clogging inside the water channels. And these solid waste are going to be breakdown under bacteria where they will undergo anaerobic condition in the mineralization tank. And the nutrient will be recovered by the waste, which is by unlocking the trapped calcium, potassium, and also iron. And these nutrients can be used as an organic fertilizer. Okay, so fourth is renewable energy integration, where our farm is going to use solar panels to power up the pumps and also the IoT. And strategic placements of the solar panels can help initiate the telepathics to control algae and to prevent any water evaporation and also increasing temperature due to harsh sunlight. And third is protection against grid failures and also power outages.
Safety and farm management. And for the safety management, the first one is optional hygiene and enter to the greenhouse, we need to wash our hands and wear the PPE. And the second one is the security, which control vehicle access to tools and equipment to very clean and healthy area. For the electrical sector, we keep the electrical equipment away from the water source, away from the fish and farming. So for the chemical safety, we properly label and store cleaning chemicals and nutrient supplements and emergency preparedness, first aid kit and fire extinguisher is backup for farm for our favor. So for the safe fish handling, we handle their carefully during breeding and harvesting, reduce the fish stress and water injury. So for our farm management, we do the daily monitoring and check the fish behavior, crop condition, and monitor the pH, physical oxygen, ammonia, EC, temperature, and humidity of the crops. For the record keeping, we feed the fish and check the quality of the water and record the growth of our crops and harvest when the day we harvest and the next day we will harvest next time. So for the routine maintenance, we clean the mechanical filter, inspect biological filter, and check pumps, taps, aerator. And the next one is feeding management. We correct quantity and schedule to avoid overfeeding. For our staff management, our water is trained to kill the tilapia fish and train how to harvest our crops. And they are giving workshop to know the hygiene and the clear responsibility of them. So for the system backup plan, aeration solar, backup power emergency and response procedure is ready. This is the farm operation of our farm operation. I pay people clean the water tank to ensure the water level in the fish tank. So after we have the we cut the waste from the fish to the mechanical filter to remove the solid waste, and solid waste will filter out to the solid collection tank and just want the solid waste from here. And we use the distribute to the biological filter and identify it by using the bacteria. Then we use the amplified solution and we mix to the water as the fertilizer for our crop. So the water will circulate and come back to the air pump. The air pump will take aeration of the tank and back to the biofilter and we go back to the water tank. Okay. Sustainability of farm by possible water recirculation. The treated water returns to fish tank and the rainwater is harvested at the pond and it can reduce the freshwater demand. So the tilapia waste provides nutrients while the biological filtration provide the nitrogen waste and the crops can absorb the nutrients from the circulating water. For the water waste reduction, mechanical filtration collect the fish solids and the solid waste is treated, mineralized nutrients is covered and not discharged. And we apply renewable energy, which is solar panels. It can help in generate energy for our irregular LP device. And the next one is environmental protection. It can reduce wastewater discharge and efficient land and water use. Vegetative aquatones can integrate with fish and crop production. Economic potential. The first one is multiple farm product. And our farm can produce tilapia fish for our lettuce, pak choy, and basil by using one integrated system. Our resource efficiency, water recirculation reduce the water inputs for the fish nutrients for production. It's efficient use for our farm by wow. And the IoT can monitoring support efficient management for the market opportunities. First, tilapia is very profitable and crop. It can support the supply the market, which is supermarket, and the farm, direct farm. Long-term economic potential, there was a diversified income from fish and crops. The continuous target crop harvesting, smart monitoring reduce labor resources waste, renewable energy reduce electricity costs, while the expandable system with demand. So to conclude,
Our farm can successfully bridge the gap between the fish farming and plant agriculture. By converting tilapia waste into vital plant nutrient and utilizing crops as a natural purifier, we can create a highly efficient closed loop system. Paired with smart IoT monitoring and renewable energy integration, our farm can offer a sustainable, practical, and eco-friendly approach to a modern food production. That's it. Thank you.
Alright. We open the floor to any question. Each group is required to ask Janet. Okay, Aerobic. Yeah. Can you explain an aerobic? This is question from the explain anaerobic in terms of this context.
So basically, anaerobic is it's a condition where the process involves so it doesn't involve any oxygen at all. So anaerobic it converts the in anaerobic conditions, the ammonia will be converted through the bacteria under environments where there are no oxygen, which transforms it into nitrites first, and then it will undergo another process through another nitrifying bacteria known as nitrobacter to convert the nitrites into nitrates, which is used for the plants.
from group 4 ada soalan. Pak, kalau ada soalan itu
Kami orang pilih tilapia sebab dia tahan rasa satu, and it's fast growing fish, and macam at the same time kita gunakan dia untuk bagi baja, and also dia fast growing. Bila dia dah besar, kita boleh harvest, and kita pun boleh jual.
kenapa tak kali?
Sebab
Okay, kalau pakai tilapia, lagi memang tilapia memang demand market dia tinggi lah. Sebab bukan saja dia senang untuk dijaga, and not only that, dia macam harvesting period dia pun sekejap je, which is around 60 to 80 days, and it also ni lah, in terms of kalau jual pun harga tilapia pun senang dijual lah, basically dia senang dijual dekat bigger market sebab it's an affordable fish to afford and to be eaten as well. So that lah. Thank you everyone. Group 2. Okay. Pak, buat nama gambar. Oh ya. Ya Pak. Sensi. Sensi. Thank you. Okay, we will start our presentation. Okay, so good morning to everyone. So for our farm design, we will choose agroforestry, and our farm name is called SCP Agroforestry. It's presented by me, Nancy, and Nini. So, as a brief introduction, kita balik kepada hutan lah. Nama pun dah agroforestry kan, so agroforestry, hutan. So forests play an important role in maintaining ecological balance, providing habitat for wildlife and fighting climate change, because they have a lot of buffer zones and biodiversity. So to explain, agroforestry in short is a forest integrated with agricultural practices. So our objective and kenapa kita pilih agroforestry? Why do we choose agroforestry? So it is to integrate crops, livestock, and aquaculture. Basically, dia macam kombinasi banyak-banyak method of farming into forest ecosystem. And then agroforestry can also improve food security as it provides a variety of food. And lastly, to provide a sustainable resource cycling system. So agroforestry was chosen because it allows the farm to produce food. Number one, produce food. Number two, generate income. Number three, conserve biodiversity. Number four, recycle resources and protect the environment simultaneously. So this is our farm layout. We use AI to generate this layout. So okay, we will explain parts by parts, and then this is our summary lah. So for every summary, we use the total length of up to 5 acres. As a brief history, this is actually a forest land
converted into a farm. So we planted crops such as there is in layout number 9, fruit tree. 9, 10, and 11 is fruit tree, which we plant durian, mango, and rambutan. And then we also have normal crops such as in the farm layout number 12, which is the corn area, and number 13 we planted here. And then we also provided farm vehicle route, which is can be made from the gate number 1, and then we also have a man-made pond for our aquaculture cultivation, which we cultivate catfish, and then we also have animals, but with mainly it's poultry such as ducks and chicken. For our chicken coop to shelter our we provided chicken coops attached with a solar panel. And then for irrigation system, let's say when eventually the soil moisture of the agroforestry farm is low, then we will use this smart irrigation system, which later will be extended by NT. And then for the biodiversity and environment, what makes agroforestry special is that agroforestry have buffer zones, which protect them from harsh environmental conditions such as high wind and even predators, diseases. So the buffer and safety zone is actually already established because it is a forest area. Just that in this 5-acre, we cut down all the trees and then give land for our vegetated crops growth and livestock cultivation. We also integrated rainwater harvesting for our water source, additional water source. But mainly we use our water source from nearby river, and then we also integrated micro turbine for hydro energy, which also generate another green electricity. But let's say when example, if there is no green electricity, for example, the cuaca mendung, and then there's low light intensity, we still provide a backup by using a generator. So this electric is to provide lights for the coop incubation and smart irrigation systems. So lastly, we also have our waste management, which is basic compost and fertilizer collection of the livestock manure. Okay, next.
Okay, we select 3 animals, which are chicken, duck, and catfish. For livestock, we choose chicken because it can be raised in control-free range area and can forage for insect and vegetation. We also provide coop for chicken shelter and their feeding, and their manure will then be used for compost. For duck, we also kept them near the pond in a controlled outdoor area. They also forage for insects and vegetation. There are also shelter provided for the duck, and their manure also will be collected for composting. So for aquatic, we choose catfish because it can easily culture in our farm pond. Besides, catfish can become our additional source of protein and income. The water from the fish pond also can be reused for irrigation after quality check. So next is the relationship between the system. So our main concept is agroforestry. So we integrate food trees, intercrops, the livestock, and aquatic. So the food trees provide products for income and also provide shade and shelter for animals. So the leaf, prune branches, and fallen fruits from the trees can also be collected as organic material. So for the livestock, the chicken and ducks will produce eggs and meat for income, and their manure will also be collected for composting. So the crop residues and animal manure will then be transferred to the composting area for decomposition. After that, the organic compost will then be applied back to the fruit tree and intercrops as organic fertilizer. For the fish pond, it also connected to the system because the water are being used to siram the crops and food trees. Okay, next is the smart farming that we use. We use two types, which is soil moisture sensor and automated drip irrigation. So this soil moisture sensor, it can help to measure the soil moisture level to prevent over or under irrigation. For the automated drip irrigation, it used when the irrigation starts automatically when the soil moisture detect when they detect the soil moisture is low. Okay, for the water management, we have three main water sources, which is rainwater, a nearby river, and fish pond. So for the fish pond, it will undergo treatment first before transferred into the water tank. So the collected water is transferred to the water tank and then pumped through our irrigation system. So the water will then pass through the automated system before being distributed to the fruit trees and in the crops. So the system we use is drip irrigation and sprinkler to supply water to the plant. So for the waste management, the main organic waste produced by our farm include prune branches, fallen leaf, crop residues, damaged food, chicken manure, and duck manure. So this material will then be collected and transferred to the composting area. So through composting, these organic waste are converted into organic compost. So the compost will then be applied back to our fruit trees and crop as an organic fertilizer. So after crop and fruit production, new plant residue will then be collected again for composting. So this about creating a circular system. So they repeat like that, like that. Okay. For renewable energy, our farm uses solar energy, and this solar energy can use to the input such as water pumps, the fish pond aerators, lighting for the cook, and for the smart farming sensor. Our farm also has natural river, so we use the flowing water to operate the micro hydro turbine as our additional energy sources. And if our energy insufficient, we also have generator as a backup. So by combining this energy, by combining these renewable energy sources and also with the backup system, we can support the reliable farm operations while reducing dependency on conventional electricity. Next, for the safety and farm management, first workers should use appropriate PPE, especially when handling fertilizers, pesticide, and heavy machinery. Farm chemicals should also be stored safely and away from livestock and food production areas. Since our farm has a fish pond and a natural river, clear signage and safe access should be provided around the water areas. And regular monitoring is also necessary. This includes to check the crop health, controlling the pests, monitoring the livestock wellness, and maintain the fish pond parameters. We also need to follow proper schedules for feeding, irrigation, and maintenance while keeping the records of our farm production, inputs, and operational expenses. Next is environmental sustainability. So our farm places a strong emphasis on environmental sustainability. We retain existing large trees rather than completely clearing the land. This can help to preserve the natural topsoil structure and reduce soil erosion. We also maintain natural vegetation along the river bank as our buffer zone to help filter the runoff water. And then poultry manure
is recycled into organic fertilizer, creating a closed-loop nutrient flow that can support the long-term soil health. For the income distribution, one of the advantage of our system is that we do not depend on only one source of income. Instead, different components of the farm provide income at different periods. First, our annual crops, such as corn and chili, can provide short-term income within approximately 3 to 6 months. This can help the farm generate income more quickly. Next, livestock and fish production can provide more continuous source of income through products such as egg, meat, and fish. Then our fruit trees, such as durian and mango, provide a medium-term income because they require several years to mature before producing the significant yields. And finally, the timber trees provide the long-term income because they require a longer growing period before harvesting. So by combining these short-term, continuous, medium, and long-term source of income, our agroforestry farm can have more balanced and economically resilient production systems. And to conclude, our agroforestry farm integrates crops, livestock, and aquaculture to create a sustainable and productive farming system. Through resource recycling, smart farming, proper water and waste management, renewable energy, and environmental conservation, the farm can improve resource efficiency while protecting soil, biodiversity, and natural water resources. The combination of different agricultural products also provide diverse income, making the farm more sustainable, resilient, and economically valuable in long term.
Thank you. Okay. Grup mana? Grup apa? Grup apa? Dia yang hantar. Grup satu. Okay. My first question is regarding the catfish pond. Fish pond. Okay. You guys have pakai irrigation, use them for irrigation. And what are you guys going to purify irrigation? Like what methods? Use multiple water filter. That's it.
Nancy already explained.
Yeah.
Dia cakap apa tadi water dari fish pond tu dia akan treatment dulu baru pergi water tank.
Yeah. Apa anda? Kalau management, selalunya ada pembahasan lah, tapi there is no infrastructure of pembahasan. Cumanya kalau pon ni kami saja untuk pakai filter lah, it's not a big scale punya proses untuk sampai pakai tu lah treatment. Maybe ada treatment tapi treatment is only for macam that punya data. That we know what to like, kita boleh tahu dia boleh pakai atau tidak lepas filter. Okay. Macam tu je. Group code. Kita orang buat dalam tanya. Atau ada kaca? Yeah. Kaca juga ada. Kalau citizen tu, habis jago tu. Okay, untuk yang tu, kita janganlah sengaja pilih tempat area yang ada kaca. Hari apa? Macam awal lain. Kalau kita boleh tengok ini, ada macam rel kan? Dia ada macam layout sendiri kan? Ada macam, taklah pagar tapi ada ni. So naturally, kalau ada human presence, haiwan-haiwan buas macam tu takkan ada lah. Ada tak kau pergi kebun mak kau? Ada kebun mak. Ada kebun kalau kau pergi experience lah. Kebun boleh sampai. Bukan kebun yang kecil tak boleh sampai meter. Kebun yang di kampung lah. For example di Sarawak. Ini experience. Kalau kebun tu dah established, memang tak adalah haiwan-haiwan macam tu. Kalau paling pun ada ular. Berapa ni? Kalau monyet tak pernah susu. Susu kita curi produce. Ya, tapi produce lebih banyak. Juga.
Sedekah.
This how we integrate environmental sustainability. Kita tak bunuh haiwan lain. Kan durian kan protein tinggi. Tak ada pakai drip irrigation.
Nah, durian tak pakai drip. Setengah je pakai.
Saya nak kurang sedikit.
Durian manually lah. Yes, manually.
Di pokok kan jarang disiram.
Yeah.
Pokok besar disiram.
Kalau fruit trees, egg crop trees, dia depend on rainfall lah. Kalau tak hujan, then manually lah siram. Nah, tanah memang perlu manual siram juga. Tapi tak ada hujan itu kemarau je, kali setahun je. Kau nanti kau tanya apa lagi? Kita di kapan ya?
Ayo deh.
Ini.
Oh, mana ini? Oh, ini katakan.
Yes, Enis.
Yang forage crop tu korang tanam paku pakis ke? Dekat farm layout.
Apa?
Aku pakai.
Paku pakis tu farm layout number 40.
Ada.
Paku pakis.
Okey, senario dia kita ulang balik lah. Senario dia dalam hutan kan. So dalam hutan, actually in Sarawak lah. Kalau paku pakis ni taklah tanam sendiri, dia memang tumbuh sendiri. That's why we call it forage crops. Forage crops ni kita handpick. Bukan ditanam sendiri.
Kita kekalkan apa yang
korang tanam tadi.
Apa ini?
Ingat kan kamu orang tanam dia. Forage
Tidak,
crop
tidak.
tu kan yang rendah maksudnya. Okey, tidak.
Okay, thank you. Tak dengar sangat. Ada lagi soalan? Boleh jawab, boleh. Ini jawab.
Tengok ini sebab. Tanya pasal pun. Waktu korang irrigate tu korang habis kecil lah kalau air tu memang up to the irrigation standards lah. Kalau orang kena ambil air tu dia water availability lah. Betul.
Tapi kami bukan main source kami. Main source kami kan air sungai dengan nyok sebagai apa? Spare. Additional.
Also pon ni just ni lah macam additional lagi
Ya.
lah nanti lah. Okay. Incredible.
ya.
Kalau sebenarnya tilapia dia fast growing lah. Tapi nak in defense juga catfish pun in high demand.
Ya.
Banyak orang masak kan. Cuma ya tilapia lebih better in terms of growth lah. Fast growing. Tilapia dalam 3 bulan lah maturity dia.
Perbandingan dia.
Catfish dalam 3 bulan.
Boleh.
Aku pun kau prefer. Mamai. Kes kopi lah.
So expert kurang ni je nak spoil dan dengan ni.
Chicken.
Otak tu korang sama dengan ayam tu dalam satu. Berarti juga.
Dia. Itu tak pasti. Itu konsep je.
Jangan terang.
Jajak. Ini lah jawab. Yang kan jawab tadi.
Kalau dalam kup dia separate. Kalau free ranging tu sama.
So macam mana dia tadi? Kurang. Macam mana dia tahu tu rumah dia? Nanti dia makan jagung.
Kalau in terms of research memang kalau ada datang lah. Kami pun tertanya soalan ni masa buat slide. So kami search and then memang macam from the egg, the chicken memang tahu perjalanan balik somehow. explanation dia detail tu lupa nak ingat, tapi dia macam tu lah dia punya cerita.
Kau yang pakai ni.
Free range chicken. So
Kenapa kau tak cerita macam ni? Kambing ke?
kalau ayam dia ayam kan dia ada telur, telur. So kita perlu lah tunggu sampai dia dua untuk generate income. Kalau ayam ya dua telur, telur, and then kalau dia dah nak boleh disembelih, baru jual daging ayam.
Ini saya kata tadi enam.
Kalau ada tanah, kita buat agroforestry.
Okay, dah. Okay. Thank you guys.
Thank you.
Pak, yang ini sikit. Baru sekarang saya
So cakap memang fokus ni lah.
Edit any.
ini suka kata ini. Ini suka kata. Okay, kita welcome Lutfi.
So, good afternoon. Hari ni kita orang nak present kita orang punya smart farming farm dari nama Grand Tech. Okay, jom. Next, okay, so kenapa kami pilih padi? So, Malaysia, especially Sarawak, mereka tengah work towards increasing paddy production to achieve self-sufficiency by 2030. So, kami decide untuk buat padi as our main crop untuk support dan respond kepada national equity. Lepas tu, kenapa kami pilih jagung? Jagung pun also an important grain consumed by both humans and livestock. So besides paddy, we decided to plant corn as our secondary crop to support food and livestock feed production. So our farm concept is smart lowland paddy and maize farm. So total plant area is 5 acres. We use smart technology to improve the farm monitoring and management. So there are few main smart farming components, which are automatic irrigation water gates, water level and soil moisture sensors, smart control room, weather station, and solar energy system. So our farm will focus on improving the productivity, water management, and resource efficiency. So ini farm layout kami. Okay, farm layout. First, kita ada divide farm ni into a few zones based on the crop requirement and farm operation. First, paddy field tu dia located close dekat automatic water gate sebab padi require more water compared to maize. So by placing the paddy field closer to main water control point, water can be distributed and managed more efficiently. And then the maize field are located separately from the paddy field sebab maize has lower water requirement. So this will allow us to use a more targeted irrigation method untuk maize. So another consideration is the location of our farm facility, which is near the main entrance. So facilities such as fertilizer storage, equipment shed, and harvest storage and waste management area is placed near the entrance to reduce the need for machinery such as tractors to traveling too close to the crop plots. So it also reduces the unnecessary movement around the crop and help to minimize the potential movement of pests and contaminants between the areas. We also have 6 meters main access road and 4 meters internal road to support the movement of workers, machinery, and harvested crop. So lastly, the drainage canals and automatic drainage gates are included to control the excess water and reduce the risk of waterlogging, especially in the lowland paddy area. So for crop selection, tadi dah cakap main crop sebab our farm is designed as a lowland farming system which is suitable for paddy production. Paddy also require effective water management, so our automatic water gate and water level monitoring system are very useful for this farm. So paddy has a production period of approximately 6 months, including the land preparation, transplanting, and crop growth and harvesting. For maize, we selected it as interim crop between the paddy seasons. There are 2.25 acres allocated for maize field. This will provide an additional source of farm income. And then the provision an additional source of farm income to support the productivity. And then the maize field, they use drip irrigation instead of using the apa inul apa nama? Lama lost. Instead of dia guna banyak air, dia guna drip irrigation, unlike paddy tadi lah. So the crop calendar ini based on different production period lah. The crop calendar will allow us to planting, growing, and harvesting activities more systematically throughout the year. So next is economic potential. So paddy is our main income crop because it is the main production activity in our farming system. Even though paddy it takes longer to harvest, it provides a planned and consistent production activity for the farm. So on the other hand, maize will provide the additional source of income as it has shorter production cycle of approximately 3 months. Therefore, it can be used as interim crop during suitable periods between paddy production cycle. So this will allow us to make a better use of available farmland instead of depending on only paddy production. And then the use of smart farming technology can also support the economic potential of the farm. For example, the automated irrigation can reduce the unnecessary water use and reduce the amount of manual labor required for irrigation. So sensors can also help the farmers to monitor crop and environmental condition more efficiently. So early detection of problems can potentially reduce crop losses. So in addition, our harvest storage area can provide a suitable place to manage harvested crop before they are transported or sold. So the combination of paddy and maize, they provide two potential sources of crop income, while smart farming can help to improve the resource efficiency and control the operating costs. So the renewable energy system used in our farm is solar energy. Based on our layout, we allocated approximately 0.2 acre, which with a stated size of around 40 meter times 20 meters by 20 meters. So the solar energy system, they can support important farm equipment such as water pump, sensors, and smart control system. So solar energy system sangat useful untuk our farm because we depend on technology for irrigation, monitoring, and automation. So using solar energy can reduce our dependence on conventional electricity and can potentially lower the long-term operating costs of the farm. So it also supports sustainability aspect of our smart farming concept because we are using renewable energy source to support farm operation. So and then moving on to the next part. Inis, mana Inis?
Okay.
Dapat dengar ke?
Dapat.
Okay, so this is our solar energy system. So this will generate electricity power daripada solar energy. Lepas tu, this electric will be supplied to the whole farm. Next. So this is our automatic irrigation water gate. So this will control water to enter from the main water source into the paddy field and also the farm. So this will dia akan control masuk according to the water level and the crop requirement. So location dia ialah dekat dengan water source to the water line of paddy field. Next. So this is automatic weather station. Akan monitor temperature, humidity, rainfall and wind speed. Kenapa penting weather station ni? Sebab if ada rain ke, ada hujan lebat ke, water gate tu tak payah function. Dia boleh directly depend dengan air hujan tu untuk grow of the plant. So selain daripada tu, kenapa dia ada control humidity lah, wind speed lah. We know that disease dengan pest dia akan transmit by wind juga. So by using this automatic weather station, dia boleh tolong farm management decide untuk bila adanya crop disease attack when the conditions is favorable. So next. Next is water level sensor. So water level sensor ni to monitor the depth of water in paddy and will send information to the control system. So kalau kita tengok dekat slide, kita dapat tengok if dia tak ada automatic tu, kita kena check satu-satu. So it is important untuk letak water level sensor dalam paddy field. Next. So next is soil health and moisture sensor. Yang ni ialah untuk kita ukur soil nutrient yang ada untuk plant, dan untuk soil moisture pula, dia ialah a sensor untuk pastikan yang field tu tak flooded. So overall dua-dua tu untuk health. Okay, so next ini ialah example kalau semua tu dalam satu sistem. So ni daripada UGM. So ini adalah satu sistem mereka use automatic weather station, automatic water level and moisture sensor dengan smart gate controller, iaitu automatic water gate. So ini ialah our plan untuk our farm juga. Next. Then we also have agricultural drone for fertilizer, where it will apply fertilizer uniformly into based on the targeted crop lah. Mana crop yang perlu banyak, kita letak banyak. Yang sikit, kita letak sikit. Next, we also have crop monitoring drone. So ni akan ambil gambar to identify poor crop growth or ada disease symptom ke or ada nutrient deficiency. Next. So automatic bird netting system is one of our pest management. So bird ni dia akan attack especially waktu grand filling stage. So to prevent this attack, kita akan install automatic bird netting system. Next. Okay, we also have harvester machine which using unmanned aerial vehicle. So ni akan harvest paddy and corn. Jadi kita orang tak payah depend on labor workforce. So instead of using the machinery yang biasa yang pakai diesel tu, kita orang akan pakai solar powered. which also controlled by button, tak payah ada orang yang control dia. Next.
Okay, for safety and management, the farm has a 6-meter wide entrance that allows vehicles and emergency vehicles or anyone to enter easily, but the visitors and vehicles should be registered and controlled at the entrance. For workplace safety, workers should wear PPE when handling chemicals or machineries, while safety signs and speed controls should be provided. So inside the farm, separate routes can be used for workers, machineries, and harvested crops. Emergency routes must also remain clear. The roads, drainage system, and equipment should be inspected regularly to prevent accidents. Next. Okay. So for farm operation, the input and control, we have weather station, soil sensor, water level sensor, UAVs or drones. All of this information will be gathered at the smart control system, smart control room, and all powered by the solar energy. So for the water management, the for paddy and drip irrigation for maize. So for paddy, there is an automated water gate which be controlled by the water level sensor. So if the water is like not enough or too much, it can sense that and sends the information to the automatic water gate. So the water gate can control the water in and out. All of those excess water will be removed through the drainage canal to prevent water loss. So for crop production, as we talked about earlier, there are paddy for 3.5 acres and maize for 2.25 acres. All of the sensors used are for crop monitoring and for the automated bird netting, which can help us to maintain healthy crops. Next. So for harvest and transport, first we did. After harvesting, the crops are transported via designated road, and so, with the tractors, all that, it will be moved directly to storage. So during in the storage where we will do grading and packing before market distribution. So for waste management, after all the grading, all the waste will be collected separately according to each section, which is organic, recyclable, chemical, or general, which will undergo treatment such as composting, recycling, or safe disposal. So this is the farm pathway. Sorry, sir. Ya, pergi. Dari pergi backward, dash. Lepas tu tekan next lagi. Next. For sustainability practices, and we use solar energy to power the sensors, pumps, and control system, which reduce reliance on conventional electricity. Water efficiency, which combines automatic gates, soil moisture monitoring, water source, and proper drainage to reduce water losses. Precision farming, which reduces UAV, weather data, and field scouting to target irrigation, fertilizer, and crop production activity. Soil conservation, which helps us to maintain field funds, to manage crop residues, and minimize unnecessary machinery traffic to reduce erosion and compaction. Reduce chemicals, where we use integrated pest management and targeted application to reduce unnecessary pesticide and fertilizer use or overuse of those chemicals. And last but not least is buffer vegetation, which we maintain trees and vegetation around the farm to reduce wind and erosion while supporting biodiversity. So to conclude, the integrated smart farm combines paddy and maize production with a planned 5-acre lowland farm. Smart technologies such as automated water gates, sensors, UAVs, weather station, and smart control system helps improve farm monitoring and management. Efficient irrigation and water level monitoring will help reduce water wastage and support healthy crop growth. Maize production between paddy seasons provide additional income and improve land utilization. Solar energy and smart automation reduce resource use and improve farm efficiency. So to conclude all that, the farm promotes higher productivity, better resource management, and more sustainable agricultural production. Thank you.
Siapa tu?
Siapa tu? Apa tu?
Siapa tu?
Siapa tu? Siapa tu? Aku baru perasan dia.
Siapa baca biru tu? Betul Ferry. Soalan dari kembali. Itu. Oh.
Kawan Anis kan?
Kawan Anis balik.
Kawan.
Anis boleh jawab apa?
Okay, soalan betul.
Tak apa nanti Anis jawab. Kan Anis?
Ya.
Tengok.
Layout. Siapa? Pergilah jawab kok. Pergi layout ni.
Yang dia. Bukan dia nak tanya.
Kita dengar station. Betul ni. Water storage. Kenapa kotak ya?
Air.
Dia ada masalah seperti erosion.
Dia macam Jakarta.
Tak, sebab tu. Tak, ini just the farm layout. So sekeliling tu dia akan ada buffer vegetation macam any pokok-pokok atau any signs of life yang kat tepi-tepi tu kami letak dia akan benda ni. So akar pokok-pokok tu dia tolong untuk prevent erosion.
Apa buffer vegetation tu? Apa buffer vegetation yang kau tanam?
Bukan tanam, dia memang asal situ.
Ya.
Okay, betul.
Ya.
Macam mana kau nak tahu tu tempat yang paling sesuai tak ada peng?
Kalau dah keliling, susah untuk buat jalan tahu.
Macam mana nak tengok?
Apa dia?
Apa Johan tanya?
Dia tanya. Apa soalan kau tadi?
Apa buffer vegetation yang contoh?
Contoh buffer vegetation yang kita ada dekat situ.
Oh Johan, kita orang tak perlu buffer vegetation pun untuk paddy dengan
Nak
orang
yang mana kan kita keliling airnya.
Ya.
Kira cakap itu tadi. Bye-bye.
Tapi kita orang pun tanam plant tu pun ada roots. Roots tu yang akan hold dia daripada erosion.
Nah, aku nak kena kat dunia ni. Nampaklah.
Painting sendiri ada. Ada lah.
Saya tanya, kau tahu tanya apa?
Johan easy tu soalan Johan ni.
iPhone bilang.
Kata.
Enak tanya.
Ya, tanya.
Kan korang plan data construction kita plan 5 ekor kan balik tanah. So adakah dari layout ini kamu dikasih tambahan kebaikan dari pagi dengan base 3 tu ada 3 0.75 adakah tu cukup 5 ekor ataupun lebih? Kenapa korang tanam lebih?
Sebab lebih kau.
Kenapa?
3.5 times 3.5 plus 2.25.
Approximately 5 acres.
Ya, kelebih
Approximately.
ya, kelebih sikit daripada 5 ekar.
Enggak termasuk lagu
Ya.
jalan.
Ya, tak termasuk.
Oh, soalnya if you guys memang tanah ekar dan 5 ekar, what is your guys punya solution? Just bagi simple solution je lah.
Reduce the Paddy
So,
field.
planning awal tu
Ya.
memang perlu buat lagi.
Ya.
Okay, betul.
Ayah. Salah.
Terus terus
Tahu lah.
Ya.
kita dari podcast di sini.
Sorry,
Saya
kami tak ada ikan.
Oh.
Sorry guys.
Nama lah ilustrasi.
Ada bentuk
Okay.
Yap. Last slide lah.
Apa hal? Apa last slide?
Okay.
Macam ni mau stop share screen tu. Okay, dah. Dah kau? Dah.
Mau in conclusion, dua besar. 3, 2, 1.
Last eh.
So we start our group present about the organic farming, and the name is Green Harmony.
Sabotage dulu.
So we know that organic farming is about we want to reduce the use of synthetic chemicals and promote the natural farming practice. Our farm propose 3-acre organic farm that focus on sustainable and environmentally friendly crop production. We planted maize and soybeans and cement crops, and by winter cropping practice. For the objective, first to improve the soil health through organic compost, and then to reuse crop residue and compost, then to improve the water efficiency and reduce waste and environmental impact. The concept is simple. We use the crop residue to be the compost, and then we bring back to the crop field. So this is the farm layout. So for buffer zone, we use bamboo of the surrounding of the farm, and then just inside and towards the center, there are storage and nursery area. These two are placed close together to make it easy for the workers to have access. And then in the right zone, in the right area, we have crops area where we cultivate maize and soybean. So in that field, we integrate the technology, and there are we use also the solar and soil moisture sensor that equipped with the solar. For storage, the roof is equipped with the solar to generate the electricity. And then separate with the crops area, we have waste management and composting area. So this is to separate the clean and to protect the crops.
And then for the post-harvest storage, it is designed to be located in a green area. So, yeah. Next. So for organic crop production, we chose maize and soybean because maize act as a cash crop where surplus can be processed into chicken feed, and we are going to sell this chicken feed. And soybeans, they help to fix nitrogen for heavy feeding crops like maize, and this helps us to improve soil fertility and reduce synthetic input. And consequently, this supports circular economy. Next. So for environmental protection, first is soil conservation. Since we are using organic farming, we are using compost, organic manure, and intercropping, which helps to improve soil fertility and reduce soil erosion. And next is water protection. Since we do not use any synthetic inputs such as fertilizer and pesticides, we can avoid chemical runoff into nearby water bodies. And we also use drip irrigation, and this also helps us to optimize water use efficiency. And the third one is biodiversity. With buffer zones, we encourage and support nearby pollinators like Apistosata and other beneficial organisms. And the fourth one is waste recycling, where crop residue will be composted and turned into organic fertilizer. And this helps us to reduce farm waste. And lastly, this helps us to reduce pollution, where we reduce the dependence on synthetic agrochemicals. And this is environmentally sustainable and friendly. So for buffer zone, what is buffer zone? Buffer zone is basically a neutral piece of area filled with shrubs and vegetation, which separates the farm from other areas. And this helps us to minimize risk of contamination. And according to my gap, low risk area adjacent to the farm, we use 3 to 5 meters for the crop zone area, and for moderate to high risk, which are areas that are near to the waste management area, we use 8 to 10 meter, as well as for roads and highway to separate it from the crop zone. And according to my organic, we recommend the slopes for crop zone. We use 1 to 2% of slope to allow water infiltration and also to reduce soil erosion. And for waste management, we also use 1.1 to 2% of slope. And for transportation, we use up to 3% of slope to facilitate vehicle movement. So for buffer crops, we use bamboo surrounding the farm, and bamboo act as a physical barrier that also help us to reduce chemical drift from external environment. And then we also use poka babaru, but this one we plan to integrate it within the farm around the crop zone area.
For um, for our water management system, we use drip irrigation system. The water comes from the main water source, and first passes through the filter to remove the particle that could clog the drip line. And then the water passes through a pressure regulator to maintain suitable water pressure, and then flow through the main line and submain line pipes, which distribute the water to the different crop rows. And then the water enter the drip lines and the emitter and will release the water slowly directly to the roots.
Nah. Itu belum.
Ini macam mana?
Tarik aku lambat ni.
Next for smart farming, we only use three types of sensor, which is soil moisture, water level sensor, and pH sensor. Next.
Okay, the rest of the recording. Okay. So our group and for waste management, crop production, lepas tu crop residue, lepas tu kita collect and separate crop residue tu macam leaf, tank, apa-apa lah berkaitan dengan organik daripada crop production. And then we collect and separate between organic and non-organic. Lepas tu composting, and then for method composting ni ambil masa dalam masa 6 bulan macam tu. Lepas tu it will return back to the crop lah as a organic fertilizer. So renewable energy, we use solar energy. Use solar energy for farm electricity. But solar power can support water pump, pump lighting, and other smart farming equipment. Why we use solar energy? Because it can reduce dependence on non-renewable energy, lower long-term electricity costs, and reduce the farm's carbon footprint. Okay, for safety, sustainability, and economic. The first one for farm safety, restore the tools and materials safely, keep working areas clean and organized, use appropriate protection equipment, and also maintain clear drainage and pathway. So for sustainability, we can protect the soil and water resources, reduce farm waste, reuse organic resources, maintain soil fertility, and protect the surrounding environment. So for economic benefit, we can reduce the fertilizer costs through composting, and reduce waste disposal costs, save electricity through renewable energy, and improve resource efficiency, and also we can support long-term farm productivity. So for the conclusion, we can conclude that we integrate organic crop production with sustainable farming practices, use companion planting and intercropping to support healthy crop growth, apply smart farming and efficient water management to improve resource use, use renewable energy to reduce dependence on conventional energy sources, and also promotes farm safety, environmental protection, and responsible resource management, and also we can reduce operating costs and support long-term economic sustainability. That's all. Wait for the new guest plan discuss. Apa? Pergi bapa discuss ni dia want to like depan dekat tepi pantai lah. Tapi kan korang tanam tepi pantai, korang pergi dekat.
Area kita biar terletak dekat tepi pantai, like nearby water bodies.
The farm kan?
Ya.
Tepi pantai.
Di pantai ada tanah kota.
Ya, dekat pantai. Sebab dia satu berangin. So patah. Dia satu. Dan panas juga. Macam mana?
Dan air pantai dia punya
Tinggi.
Okay, so ini kurang berapa? Ada dua pasti. Ah, ya, belum deh. Belum kan dalam pasal itu. Dia mau datang. Si ini saya itu ada yang spesial kita untuk ini datang dia seperti. Nanti sudah kita pantai. Pantai. Ada kan? Garam.
Mana lagi? Tempat lain.
Kami tidaklah sedang bukan pantai yang
Betul pantai.
untuk kenapa kami tanam hibiscus tu kan. Maybe sebab soil dia apakah dia dalam dia dekat pantai tu. Tapi kami just consider soil tu sedap. Maybe soil okay. Apa nama hibiscus tu maybe dia punya pertahanan hidup sedikit tu. So disebabkan tanam di pantai kan dengan dia.
So kalau tanam selain di pantai, bukan di pantai dan
Bukan directly sangat. Dia just kawasan yang maybe dia punya karakteristik tu similar to the pantai. Tapi
lagi berpasir.
maybe lah. Saya tak pada hari kita boleh samakan dan experience kot.
Sebenarnya bukan kat pantai pun.
Okay.
Maybe ada salah tu yang pasal hibiscus tu. Tapi kalau bambu betul lah.
So bambu
So yang untuk yang pokok apa hibiscus tu I don't think it's suitable. Dan ini bukan kat pantai pun.
Ya.
Macam farm biasa.
Mungkin mau hibiscus boleh je tanamkan tanam biasa. Cuma dia punya advantage dia boleh tanam dekat pantai dan juga dekat mesti yang tanam di situ. That's why you macam boleh naik berapa ke malam. Si hibiscus lagi kalau sudah baku. Ya. Kenapa ada dua jenis? Kenapa ada dua jenis? Kenapa tanaman okey tak?
Ya, soalan lain lah.
Dalam tu macam mana ke?
Kita tanam.
Ada.
Thank you guys.
Dengan itu kita habiskan sesi presentation. Ye.
Yeay, habis.
Okay, habis.